this is Poonam Saini. Today we discuss about field effect transistor in electronic devices and circuit. So what is field effect transistor? First of all, the field effect transistor FET is a 3-terminal active device that uses an electrical field. This is the main thing, that FET is using an electric field. That's why the name constitutes field effect transistor, and that field to control the current flow, and it has a high input impedance which is useful in many circuits. Or we can say that, in other words, that it is a 3-terminal unipolar semiconductor device that has very similar characteristics to those of bipolar transistors. For example, like high efficiency, instant operation, robust and cheap, and can be used in most electronic circuits applications to replace their equivalent bipolar junction transistors. Field effect transistor can be made much smaller than an equivalent BJT transistor, and along with their low power consumption and power dissipation makes them ideal for use in integrated circuits such as CMOS range of digital logic chips. Now, or we can say that FET used in many circuits constructed from discrete electronic components in areas from RF technology to power control and electronic switching to general amplification. The major use for the field effect transistor is within integrated circuits. So FET is basically used in integrated circuits, or we can say that ICs, and it is a 3-terminal device or a unipolar semiconductor device. And in this application, like which is used in FET is used in ICs. In this application, this FET circuit consumes much lower level of power than ICs using bipolar transistors technology. This enables the very large scale integrated circuits to operate. If bipolar technology was used, the power consumption would be orders of magnitude greater and the power generated far too large to dissipate from the integrated circuit. Or we can describe FET in a way like the FET uses the voltage that is applied to their input terminal called the gate to control the current flowing through them, resulting in the output current being proportional to the input voltage. So we are using the gate to control the current flowing in the circuit, and the output current being proportional to the input voltage. As their operation relies on an electric field generated by the input gate voltage, then this makes the field effect transistor a voltage operated device. So we can say that FET, field effect transistor, is a voltage operated device. Apart from being used in integrated circuits, discrete versions of field effect transistors are available, both as leaded electronic components and also as surface mount devices. Or we can say that it has a major advantage over its standard bipolar transistor in their input impedance is very high, while the BJT is comparatively low. So the basic difference between a BJT and FET is BJT is having low input impedance and FET is having very high input impedance. So this very high input impedance makes them very sensitive to input voltage signals, but the price of their insensitivity also means that they can be easily damage the static electricity. So if something is positive, then some negative points is also there. If the input impedance is high, that means it can be damaged the static electricity in the FET. So there are two main types of field effect transistor: the junction field effect transistor, we can say that JFET, and the insulated gate metal oxide insulated gate field effect transistor, that is IGFET, or we can say that metal oxide semiconductor field effect transistor, Mosfet. So this is the diagram. You can see that this is P channel and this is N channel. The only difference between this is gate, drain, source, gate, drain, source. The only difference is in P channel the arrow is outward towards the gate, and in N channel the arrow inwards towards the gate. So what is the basics of FET? Today we only discuss about the basics of FET. In the next lecture we discuss about the JFET and the metal oxide semiconductor field effect transistor. So today we are only discuss about the basics, the importance of FET in our semiconductor, in our circuit diagram. The concept of field effect transistor is based around the concept that charge on a nearby object can attract the charges within a semiconductor channel. So this is the main concept, that the field effect transistor is based around the concept that it charge on a nearby object, and that object can attract the charges within a semiconductor channel. It essentially operates using an electric field effect. The FET consists of a semiconductor channel with electrodes at higher and referred to as drain and the source. A control electrode called the gate is placed in a very close proximity to the channel so that its electric charge is able to affect the channel. This is the main point, that a control electrode called the gate, you can see in the earlier diagram, that is gate. That gate is basically is placed is very approximately close to the channel so that its electric charge is able to affect the channel. In this way, the gate of the FET controls the flow of carriers. That what are the carriers? The electrons and the holes are the carriers. So when it is placed very close to the channel, so it also controls the flow of carriers into the channel flowing from the source to drain. So it does this by controlling the size and the shape of the conductive channel. So the semiconductor channel where the current flows occurs may be either p-type or n-type. This gives rise of two categories, that is p-type FET and n-type FETs. So there are further categories like increasing the voltage on the gate can either deplete or enhance the number of charge carriers available in the channel. As a result, there are two types of enhancement mode FET and depletion mode. If we increasing or we can decreasing the charge carriers, or we can say that we can as the number of carriers increasing or decreasing, the the operation of the FET is also also changes, or either in the form of enhancement or in the form of depletion. So we discuss it in the two form, enhancement FET and depletion FET. So you can see that this is a source, this is a drain, and this is P, this is N, this is P. So this is P and P, this is gate. So these are the depletion region. This red point is the depletion region, you can see that. So as it is the electric field that controls the current flowing in the channel, the device is said to be voltage operated and it has a high input impedance, usually mega ohms. This can be distinct disadvantage over the bipolar transistor that is current operated and has a much lower input impedance. So this is the main difference between a bipolar and the FET. So in FET there is a the field effect, the electric field is basically controls the current flows into the channel, and the device is called voltage operated and having a high input impedance. Same in the meantime, you can see that bipolar transistor is current operated and has a much lower input impedance. So this is the basic difference between a bipolar junction transistor and the field effect transistor. So in a field effect transistor are widely used in all forms of circuit, from those used in circuits with discrete electronic components to those employed in integrated circuits. As the field effect transistor is a voltage operated device rather than a current device like a bipolar transistor, this means that some aspects of the circuit is very different. The bias arrangement in particular, that's why the electronic circuit designs with FET is relatively easy. It is just a bit different to that of using bipolar transistor. So or we can say that the circuits which we are going to make by using FETs are very easy as compared to the circuits which we are already made with the help of BJTs. So using FET circuits like voltage amplifier, buffers or current followers, oscillators, filters and many more can all be designed, and the circuits are very similar to those of bipolar transistors. So the circuits are same, the FET circuit and the BJT circuits are same, and the arrangements in FET is very easy as compared to the BJT. And FET is a voltage operated device and having a very high impedance, and BJT is a current operated device and having a very low input impedance. So these are the types of FETs, like field effect transistor having two, like junction and insulated gate. In the junction, there are two types, depletion and enhancement. Depletion and enhancement both are having p-type and n-type. In enhancement, both p-type and n-type. Junction is having depletion part, and that depletion part is constituted into two parts, that's p-type and n-type. So there are many types of FETs. So the first of all, we are just little bit discuss in this topic. In this presentation, we only discuss about a little bit of JFET and Mosfet. But in the next presentation, we widely describe it in a very good way. So JFET, the junction FET or the junction field effect transistor, uses a reverse bias diode junction to provide the gate connection. The structure consists of a semiconductor channel which can be either N-type or P-type. A semiconductor diode is then fabricated on the N channel in such a way that the voltage on the diode affects the FET channel. In operation, this is a reverse bias, and this means that it is effectively isolated from the channel. Only the diode reverse current can flow between the two. Or we can say that this is a reverse bias, and this means that it is effectively isolated from the channel. Only the diode reverse current can flow. So because of that reverse bias, only the diode reverse current can flow between the two junctions, and JFET is the most basic type of FET, and one was developed. It is still provides excellent services in many areas of electronics. JFET is basically works on the process of reverse biasing, and in this operation only the reverse current can flow, diode reverse current can flow between the two junctions, and it already used in earlier, and it provides a very excellent services in many areas in electronics. And second type we discussed, that is metal oxide semiconductor FET, and we can say that insulated gate FET. The Mosfet uses an insulated layer between the gate and the channel. That's why it is called insulated gate or metal oxide, because the channel, the insulated layer, is a metal oxide semiconductor layer. So that's why we can say insulated gate, or we can say the metal oxide semiconductor, both. So this is formed from the layer of oxide of the semiconductor. That's why it is known as metal oxide. The name IGFET refers to any type of FET that has an insulated gate. The most common form of IGFET is the silicon Mosfet. So the most common is silicon. That's why, as the name suggested, we already thought that the oxide layer of the semiconductor is made up of silicon, so that is known as metal oxide silicon FET. So metal oxide, the gate is made up of a layer of metal set down on the silicon oxide, which is turned in on the silicon channel. Mosfets are the widely used in many areas of electronics, and particularly within integrated. Mosfet are today we use MOSFETs widely in electronics and as well as in the integrated circuit. When we go through, in the next more slides, when we talked about integrated circuits, we have to talk about the metal oxide layers. So there are key factor of IGFT and MOSFET is the exceeding gate high impedance that FETs are able to provide. That said, there will be an isolated associated capacitance, and this will reduce the input impedance as the frequency rises. As the frequency rises, this will reduce the input impedance. Apart from selecting a particular type of field effect transistor for any given circuit, it is also necessary to understand the different specification. In this way, it is possible to ensure that the FET will operate to the required performance parameters, and FET specifications includes everything from the maximum voltage and current. So we can say that there are many advantages over the BJT and there are many disadvantages. FET is having both advantages and disadvantages. So field effect transistor technology can be used in number of areas where bipolar transistors are not as suitable. So each of these semiconductor devices has its own advantages and disadvantages and can be used in great effect in many circuits. So we can see that BJT is basically a current control device and the FET is basically BJT is a voltage operated device, FET, and BJT is a current operated device. The only difference is high input impedance and this is low input impedance. So FET circuits, FET is working on the field effect field, and there are many types like enhancement, depletion. On that we are difference between on that we are having two categories, JFET, that is called junction field effect transistor, and IGEFT, that is insulated gate field effect transistor, or we can say that metal oxide semiconductor field effect transistor, metal oxide silicon field effect transistor, or Mosfet. In the next slides we are going to talked about JFET and Mosfet in a very broad way. So in the next slides, apart from this, we are going to discuss more about ICs and MOSFETs and JFET. Thank you.